In previous videos, we have talked about implementing an IBC precompile for the Ethereum virtual environment, and I have showed you a demo of a prototype built with Evmos. Evmos brought the EVM and the Cosmos ecosystem together, so right now it is the best base layer to implement this IBC precompile, which gives access to the inter-blockchain communication protocol from Cosmos directly from the EVM. With it, you will be able to create smart contracts that send messages to other chains with IBC support. Another important use case is building interchain bridges using the already existing IBC infrastructure. And today you will see one of the types of bridges that can be done, a generalized replay bridge between two chains that have support for both the EVM and IBC. And I will demonstrate it on two Evmos chains. A generalized replay bridge can replay smart contract transactions on one or more chains, keeping state of any type in sync across chains. And this can be done selectively for the smart contract state that you are interested in. For example, for keeping token balances in balance across contracts. And you do not need to replay all the transactions of a contract, but only the state changes that matter. So this technique also works well with rollup systems or with any application-specific chain that wants to keep its most important state in sync with the main chain. We have two Evmos chains running. This is the first one, the second one, and here is the Hermes relayer, which will relay any packets sent from one chain to the other through IBC. And I have already created a channel between these two chains, channel 0. On each chain, I have deployed a bridge main contract and a test contract. This test contract is a smart contract that keeps a state which will be synchronized across chains, and the bridge contract is the one who will change the state in the test contract. So I have a dApp here that works on the first chain and another dApp here that works on the second chain. Syncing state is done in 3 steps. 3 transactions: play, replay, and finalize. We will do the play transaction first. So we need the name of the second chain, the target address, which is the address of the test contract, and here in this setup, the contracts have the same addresses on both chains. And the call data, this will call the set function on the test contract and set a value of 5. The current value is 8 on both chains. This play transaction creates a new state hash for the target contract and stores it in a pending state in the bridge main contract. It also sends an IBC message to the second chain with this hash, this new hash. So we'll click on the play transaction. We will confirm the transaction and we will see how Hermes picked up the message, and now it should be relayed to the second chain and we can see it here. Okay. At this point, the value is still 8 and we need to do a replay transaction. But let's see the messages that we have for our chain. So this is the IBC precompile interface. We are using channel 0 and we want to query the messages that the bridge main contract has received. And this is the hash that was sent by the play transaction. So we go back here and we do the replay. We get the ID from the first chain. The target address is the test contract address, and the call data is the same as we had in the play transaction. what the replay transaction does, the bridge contract from the second chain checks the IBC messages that it has received, gets the state hash, and compares it with the state hash computed from the previous test contract state hash and this new call data. If they match, it applies the call data to the target contract and sends back another IBC message to the first chain. So let's do this transaction. And we'll see Hermes picking up the message here, and we should see it being received by the first chain here. At this point, the state should be changed, and it has a value of 5 on the second chain. On the first chain, the state remains the same, 8. But now we can go to the IBC precompiled app, because a precompile is a smart contract, so we can query and call its functions. And we want to get the messages for our bridge main contract. And this is the state hash that we have received. It should be the same state hash that this bridge contract sent to the other chain in the play transaction. So right now, we need to finalize. And we will use the same call data, and we can finalize the transaction. What happens in the finalize transaction is that, and now the value is 5. The bridge main contract checks what IBC messages it has and compares the hash received in that IBC message to the pending hash that was stored when we did the play transaction with the computed hash from this call data that we provide here. And if all three match, it applies the call data on the target contract, which in this case is the test contract. This is a generalized replay bridge in 3 steps for any kind of state changes for any smart contract. The pending state also allows us to lock the states from other contracts that depend on the synced state and implement a semaphore pattern. The bridge has the same trust assumptions and security as using IBC and the Cosmos SDK. It is generalized based on transaction replay. It is extensible, it can be used to bridge more than 2 chains, and it's compatible with the EVM data service, or EDS, for data mirroring and data sharding. There is a lot more to be shown, and future demos will follow.